Hi, it's Miss Reese. I'm going to be explaining some questions on page 7 and 8. You should have already completed the toolkit video for this. We're on page 7. So after looking at the toolkit, now you should know how to set these questions up. Let's get through a couple of them together. When we have two equations, both equaling y, that means these equations are equal to each other. So when we write this out, I'm basically replacing this y in the second equation with the value of y, 3x plus 19. That's what we call substitution. So we should be able to say 3x plus 19 is equal to 5x plus 33. So we're solving for x here. We want to bring all of our variables to one side of the equation, all of our regular numbers to the other side of the equation. I'm going to bring all my variables to the left, and I know that 3x minus 5x, that's going to give me 2x, and we still have the 19 there. 5x minus 5x is 0, and then we still have 33. Okay, now we can subtract 19 on both sides. And when we subtract 19, we're bringing all of our regular numbers to the right side. So on the left, we're going to be left with 2x, and on the right side here, we are going to be left with 14. Okay. Now that we know our value for x, when we divide by 2, we're going to get 7. We can use that to help us figure out our value for y. So we want to express our answer in a coordinate point. So we know x is 7. This is our solution here. And to figure out the y part of it, we need to just plug that back into our equation. So I know that y equals 3 times, we just figured out x was 7 plus 19. So whatever you get for your y value here, you can plug in for y in your coordinate point. Okay. Question 2, you can set up in a similar way. And then you're going to get to questions where they both don't say y equals. So instead, we can take the value of y here and put it into our other equation, substitute it. So we can say that x plus y in our other equation. Oh, remember, we're not using y this time. We are replacing it with the x plus 8 equal to 2. Now we're going to combine like terms. Remember, when our variables are on the same side of the equation, we want to just combine them, add them together. So from here, you should be able to solve for x. Once you know the value of x, you can use that to solve for y. Okay. And you're going to be doing that for the rest of this packet, or the rest of this page here. So substituting in, all of these are set equal to one variable. So we got y equals 2x. You're going to plug that into the y down below in our equation here. Okay, we've got y equals x plus 2. We're going to be plugging that into our equation, or our y variable here. We've got x equal to 3y. I'm going to plug that into x, or substitute, replace it. Y equals 2x plus 1. We're going to put that in for y. This one especially, I would make sure you're putting a set of parentheses around it. So 2x minus our y value, which is 2x plus 1, which we substituted, equals 3. And we want to make sure we put the parentheses because we want to make sure we're distributing that negative to both terms. Okay, and then in our last set of equations here, we have an x equals, and we're going to plug that into x in our equation above that. Now on page 8, we're going to look at graphing versus substitution. I'm not going to do question 1 with you. Let's try question 2 together, actually. So on question 2, in order to graph these, we would want them to both be set equal to y. So in my first equation here, I would subtract 5x from both sides, bring that to the other side. I'm left with a negative y equals negative 5x minus 5. Now, because I want this to say y equals, I'm going to divide everything by negative 1. And that's going to give me y equals positive 5x plus 5. You can then graph that equation on your coordinate grid here. Okay. Now our second equation, I'm going to do in blue, is we'll subtract 3x on both sides. Now when I do that, I get negative 6y equals negative 3x plus 24. Now from here, I can divide everything by negative 6. And that will give us y equals negative 3 divided by negative 6 is positive 1/2. Negative divided by negative is positive. And then in our 24 divided by negative 6 is negative 4. So you should be able to graph both of those equations on our coordinate grid here. And then you're going to compare the point of intersection with your solution when you solve this using substitution. Now I'm going to take this equation here, and we already rewrote it to say y equals. So y equals 5x plus 5. So now that we have an equation that says y equals, you can take the value of y and substitute it into y in your second equation here. So you'll be solving for y first. Once you know the value of y, you can solve for x. You will need to do that for some of these equations here. Like you'll need to make sure one of your variables is isolated. So you can use substitution in this equation here. And we already have the value of x in our fourth equation here. So that should be an easy substitution. We already know what x equals. So for our solution, we can say x equals negative 3. Now we just need to figure out what y equals. First part's already done for us. And then on the last one here, you should be able to go ahead and substitute the value of y into your equation.